Alright, so we're on to section 9.6, identifying symmetry. There's three different kinds of symmetry. Alright, there's three kinds. Three kinds of symmetry. Alright, and the first thing I really want to do is, you're probably familiar with a lot of them. I think that a lot of them you'll see pretty apparent. So I want to just kind of talk about them before we actually formally define them. So I've got several pictures up here. Let's look at this first picture. Let's talk about maybe the most common form of symmetry, line symmetry. Alright, so if, for instance, I took this first picture, we'll call it picture 1, I take picture 1 and I want to find line symmetry. Well, I can find a lot. For instance, if I took a line and drew it in right down between these two, kind of down the middle, that would be a line symmetry. And basically I could fold kind of the left side over here onto the right side. It would be it would perfectly line up. It would line up perfectly. Okay, so that's one line symmetry in this picture. I think there's another one going like this. You'd probably agree. It kind of cuts it from left to right. I also think that there's one going up and to the right like that. I think that would be one also. I'm sorry, I think I said there's three different kinds. I'm sorry, there's two. There's two. Sorry, line symmetry, rotational. Okay, there's two. Anyway, and then if I took and maybe went the other way, I think if I folded it over like that, that would be another line of symmetry. So far we've got 4, and I don't think I can find any more on this one, so I think that's going to be 4 lines of symmetry. I'm looking at 4 lines of symmetry on this one, right? 1, 2, 3, 4. 4 lines. Whoa! 4 lines of symmetry. You know what? You can just write that wherever you've got room. There's 4 lines of symmetry. Let's look at this butterfly over here. And I want to figure out how many lines of symmetry this butterfly has. Where can I fold it over perfectly onto itself? And it looks like maybe I've just got one kind of going right through the middle here. If I folded the butterfly over, which would be an incredibly mean thing to do. But if I did that, the wings look like they match up pretty much perfectly, which is kind of a neat thing about the butterfly, that it is symmetric on each wing, that their wings kind of match. So if we kind of move down the thing here, this cow, we could maybe call this cow Ned. Ned the cow here. If we could find symmetry in Ned's face, it would probably be right down the middle if we kind of folded his face over, which would be an incredibly inhumane thing to do. But if we did that, he would have a line of symmetry right there. So those two have one line of symmetry. Now the starfish thing over here, that's not, I think it's a starfish, I don't know, I'm not a biologist. But the starfish thing, I think it's going to have maybe more than one line of symmetry here. So let's look. I think there's one, just if we kind of draw one in like that. What do you think? I don't know. I think that's one. And these 2s and 3s. Okay. There's one right there. And then I think because we could kind of fold this end tentacle over to this end tentacle and everything would kind of match up, there's another one going like this, right? And another one kind of going right here like this. And let's see, I think we can kind of keep going here, right? Kind of through each tentacle thing, he's going to have a line of symmetry, and he's got 5 tentacles. So, yeah, that's, he's got 5 lines of symmetry. Now, sorry, my drawing got kind of goofed up here, but we could count our lines here. We've got 1, 2, 3, 4, and 5, and at that point I think we're talking about the same line again, right? Because this next line down is line 1, so there's 5 lines of symmetry in that one. Okay, now I'm going to clear my screen here, so you might want to pause, make sure you've got that all jotted down. We're going to talk about rotational symmetry next, okay? So, cool, everything's gone. And now I've got, this is a benzene molecule, benzene, and yeah, I don't know much about this except that it's got some pretty cool symmetry. So if I rotated, if I kind of picked my center of rotation and I rotated about the middle of the picture and rotated it around either direction, you know, maybe this way, then I think I could rotate that and it would kind of land right on itself. Okay, and that's what we want, is to take the original, move it, rotate it, and make sure that it's mapped onto itself. That's kind of the definition of symmetry. We're mapping things onto themselves. Okay? So that would be one rotation. We could maybe even do two. I think we would end up in the same place. Oh, excuse me. I'm wrong. These kind of C things in the center mean that we've got to go all the way over here to put this line C in the right place up here. Okay, so never mind. We've got one rotation that will put us in that position. Okay, so that's got some rotational symmetry. I think you could probably even make the argument that it's got some line symmetry too. I think, you know, if you went right down the middle here, I think you could fold it over onto itself just fine. If you went kind of through there or through there, it's got some line symmetry. Okay, let's look at the last picture here. This one definitely got some rotational symmetry. What's special about the rotational symmetry is that it has to be less than 180 degrees. We don't care about anything bigger than 180 degrees, even though it may exist. We just want it between 0 and 180 degrees. So, to figure out my rotational symmetry, and I wanted to maybe rotate it counterclockwise, one turn, so I got to figure out how far that is. Well, I've got three angles in here, right in the middle, around the center of symmetry. I've got three angles. So if I take all of those, 360 is how much they total, right? And if I go all the way around, it's 360. Divide that by 3, that's going to give me 120 degrees. Okay, so this motion here is 120 degrees. And that's it, because if I go further, if I go around one more, then I'm going 240 degrees. We want to keep it less than 180. Okay, so that's what we mean by rotational symmetry. And why didn't my darn equal sign show up here? There. Equals 120. That's what we mean by rotational symmetry. So two types, line and rotation. Let's actually define line symmetry real quick here. Okay. Okay. Definition of line symmetry is the picture has to be mapped onto itself about a line of symmetry. Line of symmetry. And that's it. There could be lots of them too. Remember that. There could be many. And if you would just pause real quick for a moment of interruptions while I bring up the next picture here that we're going to use. Oh, shoot, not there yet. We're getting there. Don't worry. I promise you will have. The next thing will be up there soon. Okay, done. And click. Here we go. Okay. What do you think is meant by rotational symmetry? We'll go through this fairly quick because I don't want to waste your time. This means that we're going to be mapped. The picture is going to be mapped. And that was my phone going off. Mapped onto itself. By a rotation of 180 degrees or less. By a rotation of 180 degrees or less. That's it. I rotated 180 degrees or less, then I've got, and I just put that in center of symmetry. Wow. Well, that's an excellent job. This actually goes up here. Okay, sorry, that's rotational symmetry. This lesson is going phenomenally, but that goes up there. I apologize. And then let me give you an actual definition for center of symmetry. The actual definition for center of symmetry is the point at the center of an object with rotational symmetry. And that's it. Okay, so that's what we got by the center of symmetry. I'm going to kill this video here, and we're going to do one more video of those last 3 examples on your sheet, and then we'll call it good. So this will only be a 2-parter if I can figure out how to close out the video. Okay, have a nice 2 minutes as you switch to the next video.